Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Port address, translation commonly referred to as PAT, is one of the most important technologies that make modern networking over IPv4 possible. While the number of public IP addresses is limited, the number of devices that need to connect to the internet continues to grow. PAT solves this imbalance by allowing multiple internal hosts to share a single public IP address while still maintaining the ability to initiate separate and simultaneous outbound sessions. It accomplishes this by using port numbers as unique session identifiers, enabling large-scale connectivity without requiring additional public IPs. This episode focuses exclusively on how PAT works, why it's used, and what you need to know for the Network Plus exam. It builds on foundational NAT knowledge, digging deeper into how port mapping works and how traffic is translated in real time. Expect this topic to appear in exam questions involving addressing, routing, session behavior, and router configuration. You may be asked to identify which NAT type allows many-to-one translation, interpret a PAT table, or troubleshoot connectivity issues caused by incorrect port forwarding or address overload. PAT works by translating multiple private IP addresses into a single public IP, but it does so using port numbers to differentiate between sessions. When a device on the internal network initiates a connection to the internet, the PATMEN router assigns it a unique source port number and maps that port to the internal IP and original source port. This combination, the source IP, source port, destination IP, and destination port, becomes a temporary entry in the translation table. Because thousands of distinct ports are available, hundreds or even thousands of internal hosts can share a single public IP simultaneously. Port numbers are central to PAT's operation. Every time an internal device makes an outbound request, it's assigned a high ephemeral source port number, which becomes part of the unique translation entry. This allows the NAT device to track multiple sessions between internal and external addresses, even if they all share the same public-facing IP. When return traffic comes back from the internet, the NAT device uses the destination port in the incoming packet to locate the corresponding internal IP and port. This enables accurate and efficient routing of the response traffic to the correct internal host. PAT translation table stores each of these mappings while the session is active. Each entry includes the internal IP and port, the translated external IP and port, the destination IP and port, and a timestamp. These entries remain in the table until the session ends or until an idle timeout occurs. When the timeout is reached, the table entry is purged to free up the port for future use. This temporary storage ensures that the device can manage thousands of concurrent connections without long-term commitment of public IP resources. PAT differs significantly from static and dynamic NAT in terms of both operation and efficiency. Static NAT maps one internal IP to one public IP, and dynamic NAT uses a pool of public IPs to assign addresses as needed. PAT, in contrast, uses only a single public IP and differentiates sessions based on port numbers. This makes it vastly more scalable than either static or dynamic NAT, particularly for organizations with limited access to public address space. It's no surprise that PAT is the default method for internet access in most home routers and business networks. PAT is most commonly used in scenarios where many internal devices require access to the internet, but only one or a small number of public IPs are available. A typical home router uses PAT to allow all household devices, phones, computers, tablets, and smart TVs, to browse the internet through one ISP-assigned IP. In businesses, edge routers often perform PAT to provide internet access to internal clients while protecting private IP ranges from exposure. This widespread use makes PAT one of the most important concepts to understand in IPv4 network design. Despite its advantages, PAT does have limitations. The total number of sessions that a PAT-nated device can handle is finite, limited by the number of available source ports, typically around 65,000. When this limit is reached, new outbound connections may fail until older sessions are closed or time out. Additionally, some protocols that require inbound connections or complex session setups, such as SIP for voice or certain VPN protocols do not always work well through PAT without special handling or configuration. To allow inbound access to a device behind PAT, port forwarding must be configured. This creates a manual mapping from a specific port on the public IP to a designated internal host and port. For example, if you want a web server inside your network to be accessible externally, you could configure your router to forward TCP port 80 from the public IP to the internal IP address of that server. This allows incoming traffic to bypass PAT's default behavior and reach the intended internal system. Port forwarding is essential for hosting services behind PAT. Applications do not always behave well when PAT is in use. Some older or peer-to-peer applications embed IP addresses inside the payload of the packets rather than relying entirely on header data. This causes issues when NAT devices alter the headers but not the embedded content. Modern protocols and applications often include NAT traversal features, but some still break or degrade under PAT. VoIP systems, online gaming platforms, and streaming tools may require additional configuration or workarounds to maintain reliable performance. Troubleshooting PAT issues involves several diagnostic strategies. Session timeouts are common when connections sit idle for too long and are dropped from the translation table. In such cases, reconnecting or increasing the timeout settings may help. Misconfigured port forwarding rules can also lead to connectivity failures for inbound connections. Additionally, port conflicts can occur when multiple internal devices attempt to use the same port simultaneously. Most NAT devices are intelligent enough to manage these conflicts, but in high-traffic environments, port exhaustion and conflicts may still impact performance. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. When it comes to logging and auditing, PAT offers valuable insight into how devices are communicating with the outside world. Every session that PAT handles generates a translation entry, and these entries are typically accessible via logging features on routers and firewalls. These logs provide information on which internal IP initiated a connection, the assigned source port, the destination IP and port, and how long the session remained active. This is particularly useful in environments that require compliance tracking, forensic investigation, or simply visibility into user activity. Logs can show which device accessed what resource and at what time, enabling administrators to trace issues or security incidents with accuracy. Session persistence under PAT is maintained as long as the connection remains active. This means that a session between an internal host and an external server will retain its port mapping for the entire duration of the interaction. However, once the session becomes idle and exceeds the timeout value configured on the NAT device, the entry is removed from the table. This cleanup process ensures that resources are freed up for new connections. But it can disrupt long-running services that rely on persistent but infrequent communication, such as certain remote access tools or intermittent data sync services. In some environments, PAT is deployed across multiple WAN interfaces, especially when load balancing or multi-homing is used. In these configurations, the NAT device may have more than one public IP address and distribute outbound traffic based on routing policies or bandwidth availability. PAT must then track which session is associated with which WAN interface and public IP. This complexity requires the NAT table to include interface data or routing tags to ensure that return traffic follows the correct path. Misrouting in these setups can result in dropped sessions or asymmetric routing issues. PAT operates using source port numbers to differentiate sessions. Typically, NAT devices assign high ephemeral ports, those in the range of 49,152 to 65,535, for outbound translations. When the available port range is exhausted, the NAT device must either wait for sessions to close, reuse idle ports, or refuse new connections. Some devices are capable of reusing ports under certain conditions, but this requires careful conflict management to avoid misrouting responses. In extremely high traffic environments, port exhaustion can create bottlenecks, and performance tuning becomes necessary to maintain connectivity. Scalability is one of PAT's biggest strengths, but it also introduces resource demands. Each session tracked consumes memory and CPU resources on the NAT device. As the number of concurrent users and sessions increases, so does the load on the device. In enterprise environments with thousands of users or in service provider networks, the NAT infrastructure must be sized appropriately. This may involve using higher capacity hardware, distributing sessions across multiple NAT gateways, or implementing session timeout tuning to optimize table turnover. Failure to scale PAT infrastructure properly can lead to slow connections, dropped sessions, or total service outages. Different vendors implement PAT in slightly different ways. The basic functionality remains consistent, but terminology, configuration syntax, and feature sets can vary. For example, Cisco devices may use specific NAT commands and access lists, while Juniper may refer to source NAT with different control structures. Some vendors use the term overload for PAT, while others may refer to it as dynamic source NAT. Despite these differences, the underlying behavior, translating many internal sessions to a single public IP using port numbers, is largely standardized and recognized across platforms. You may also encounter the term NAPT, which stands for Network Address and Port Translation. This is simply another name for PAT and is used more often in academic literature or documentation. In practice, PAT and NAPT refer to the same concept, using port numbers in addition to IP addresses to distinguish between multiple, simultaneous connections from a private network to a public network. Recognizing both terms as interchangeable is important for understanding documentation from various vendors, textbook references, and exam material. On the Network Plus exam, questions about PAT often involve recognizing its role in diagrams or configuration examples. You might see a scenario where multiple users are browsing the internet through a single IP and be asked which NAT type supports that function. You may be shown a translation table and asked to interpret which internal session corresponds to which external connection. Questions may also test your understanding of port forwarding, where external requests to a public IP and port must be directed to a specific internal IP and port. These are practical skills that mirror real-world configurations. Being able to identify PAT behavior also helps when troubleshooting NAT problems. For example, if only one device can access the internet at a time, it may indicate that static NAT is being used instead of PAT. If a service such as remote desktop is unreachable from outside the network, it may mean that port forwarding has not been set up correctly on a patman's main state, is essential for diagnosing and resolving such issues quickly. In summary, port address translation is a core technology that allows modern networks to function effectively despite the limitations of IPv4 address space. By mapping many internal sessions to a single public IP through port numbers, PAT ensures that households, businesses, and even large enterprises can access internet resources without needing a unique IP for every device. It's efficient, scalable, and supported on virtually all NAT-capable devices. For exam preparation and real-world implementation, mastering PAT means understanding how it works, where it fits, and how to apply it to connect private networks to the broader internet securely and efficiently. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cyber Security Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.